In this question, we want to solve the exponential equation using the method of relating the bases by first rewriting the equation in the form b to the u equals b to the v. This equation is the square root of 3 equals 27 to the x. So the directions have specified what method we're going to use here. And our goal is to rewrite our equation so that we have the same base on both sides. On the left-hand side, I've got square root of 3, and I can write square root of 3 as 3 to the 1/2 power. That's writing that with a base of 3 and a power of 1/2. On the right-hand side, I have 27. And 27 is the same thing as 3 times 3 times 3, or 3 cubed. I can write this as 3 to the 3rd power, and I would need to carry down that x that was already in the exponent. I can use the power rule for exponents on the right, raising a power to a power, and we simplify by multiplying those powers together. That would be 3 to the 3x. Now I've written this in the format that was mentioned over here, having the same base on both sides. And our method of relating the bases says that once we write it in this format, that the exponent on the left needs to equal the exponent on the right, allowing us to simplify this equation. We can write it as 1/2 the exponent on the left equaling 3x the exponent on the right. So this gives me a simpler equation, and I'll solve by getting x by itself. So I can divide both sides by 3. And when you divide fractions, you want to multiply by the reciprocal. So this is 1/2 times 1/3. The reciprocal of 3 is 1/3. And that's x equals 1/6. So 1/6 is the solution to this exponential equation. On this question, we want to solve the exponential equation using the method of relating the bases by first writing the equation in the form e to the u equals e to the v. Now, the advantage of writing it in this format is that once something is in this format, we're able to use this relating the bases method to simplify the equation. When you have e to the u equals e to the v, that means that the exponent on the left has to equal the exponent on the right. The equation that we have in this example is e to the x squared equals e to the 3rd over e to the x squared. So first we need to rewrite it so that we have this format of e to a power on the left. We already have that in our example, e to the x squared power. And we want e to a power on the right. On the right, we need to use some of the exponential properties to combine these bases together. On the left, we have e to the x squared. On the right, we're going to simplify this portion using the power rule for exponents. So we're going to simplify e to the x squared using the power rule, and we would multiply those powers together to get e to the 2x. Then we're going to simplify the fraction on the right using the quotient rule for exponents. When you're dividing expressions that have the same base, you subtract the exponents. So e to the 3rd over e to the 2x is e to the 3 minus 2x. Now we've written the equation, so that the bases are the same on both sides, and we can now apply the relating the bases method, saying that the exponent on the left is equal to the exponent on the right. This gives me a quadratic equation. I'll move all the terms to the same side. That gives me the equation x squared plus 2x minus 3 equals 0. We can solve this by factoring. X times x is x squared. 3 times 1 is 3. We're going to get a positive 3 and a negative 1. Now that I've factored, I can use the zero product property and set each one of these factors equal to 0. And that gives me x equals negative 3 and x equals positive 1. The solutions to this equation are negative 3 and positive 1. On this question, we want to solve the exponential equation using the method of relating the bases by first rewriting the equation in the form e to the u equals e to the v. The equation we're working with is e to the x squared equals e to the x times e to the 12th. Now with the method of relating the bases, we want to write it so that we have e to the u equals e to the v. And once it's in that format, we can simplify by saying that the exponent on the left is equal to the exponent on the right, giving us a much simpler equation to work with. In this example, we have e to the x squared. We already have a base of e on the left, but on the right, we have multiple expressions with the base e. We want to combine these together using the properties of exponents. We have e to the x times e to the 12th, and when we multiply expressions with the same base, we would add the exponents together using the product rule for exponents. So we're able to simplify that e to the x times e to the 12th to be e to the x plus 12. When we're multiplying with the same base, we add the exponents. Once we have the same base on both sides, we're going to apply that relating the bases property and say that the exponent on the left has to equal the exponent on the right. This gives me the quadratic equation x squared equals x plus 12. I'm going to move all the terms to the same side. And now I have the equation x squared minus x minus 12 equals 0. I can solve this quadratic equation by factoring. X times x is x squared. 4 times 3 is 12. I'll use a minus on the 4 to get the minus in the middle and a plus on the 3. Now I have it completely factored, and I'll use the zero product property to break this into two equations. X minus 4 equals 0 and x plus 3 equals 0. I'll solve each one of these equations to get x equals 4 and x equals negative 3. And I have the solutions to my equation being a positive 4 and a negative 3. Thank you for checking out my videos. Have a great day.